today's objectives, the student will be able to solve compound inequalities. Graph the solution set of compound inequalities. The essential questions. What are compound inequalities? How do we determine the solution set to a compound inequality? A compound inequality is two or more inequalities connected by the word and or by the word or. For example, 3 is less than 2m minus 1 is less than 9. This is an and statement. 2x minus 3 is greater than or equal to negative 1, or negative 3x minus 7 is less than 3. This whole section is an or. What's the difference between an and or? An and means intersection. What do the two items have in common? If you have item A and item B, what do they have in common? Only this section here in the middle. Or means union. If it is one item, it's in the solution. Here is your items bank for A. Here is the circle item bank for B. Union means we're going to put it together. Everything in A and B are solutions. We're going to graph x is less than 4 and x is greater than or equal to 2. Let's start by graphing just the first one. X is less than 4. Open circle of 4 and everything to the left is shaded. Let's graph x is greater than or equal to 2. This time we're going to have a closed circle at 2 and everything to the right. Because it is an and statement, we need just the portions where the two intersect. Your final solution would be to combine the graphs where they intersect each other. You can see right here that if we overlap, between 2 and 4 is where they meet. Where do they intersect? Only between 2 and 4 is an open circle. Now we're going to graph an or statement. Graph x is less than 2 or x is greater than or equal to 4. The graph of x less than 2 has an open circle at 2 and we shade to the left. The graph for x is less than or equal to 4 is a closed circle at 4 and we shade everything to the right. When we combine the graphs, we take all of the solutions for the first one, all of the solutions for the second one, and put them together. To graph a compound inequality written together, we can always break it up. It is written the same way as this. 6 is less than m, and m is less than 8. Many of us do not like it written with the m on the right-hand side. We can switch the order and say m is greater than 6 and m is less than 8, and graph it the way we just did. However, it is always easier for an and statement to just graph the solutions between 6 and 8. Open circle at 6 from this inequality. Open circle at 8 from the right side of the inequality, and everything in between is shaded. For example, we have 2x is less than negative 6 and 3x is greater than or equal to 12. First thing we want to do is solve each inequality for x. We have 2x over 2 is less than negative 6 over 2. Dividing both sides by 2, we get x is less than negative 3. In the second one, 3x is greater than or equal to 12. Divide both sides by 3. X is greater than or equal to 4. Next, we want to graph each inequality. This one is x is less than or negative 3, so we're going to have an open circle at negative 3, and we're going to shade to the left. In this one, we have x is greater than or equal to 4, closed circle at 4, and we're going to shade to the right. Combine the graphs. We're going to take the graph of the first equation and the second equation, because it is an and statement, and combine them. You're looking at the graphs where this open circle is at negative 3, the closed circle is 4, and they both go in opposite directions. Where do they intersect? Because we are looking at an and statement, it's important to figure out where they intersect. They do not. X cannot be greater than or equal to 4 and less than negative 3. There is no solution. This only happens with an and statement when both of your solutions have no overlapping parts. In this next one, we're going to graph 3 is less than 2m minus 1, which is less than 9. The first thing that we want to recognize is because it is written together, this makes it an and statement. Remember, when we're solving an and statement, we can rewrite it so that it's two equations. 3 is less than 2m minus 1, and 2m minus 1 is less than 9. This portion in the middle gets shared by both equations, for the one that is with 3 and for the one that is 9. We follow the same steps as we did last time. Solve for m. Then we want to graph the intersection, which is 2 is less than m and m is less than 5. You'll notice that they're both open circles. First one's at 2, the second one is 5. Because m is in between, we want all of the solutions between 2 and 5.